4, 1.5, I think this one, like that. That means you have go through chapter 1, go through section 3, section 4, and section 5. This one, yes, only, that's right. Only, and this one, yeah, there's, for example, 2.1, suppose, like that. Okay? And we have a dynamics. Also, we have 4 questions. And finally, we have equilibrium. Sorry, I made a mistake. This is 5, and equilibrium here 4. I'm sorry. So mainly, Ishbab, kinematics and dynamics will contain 10 out of 15. So don't spend your time on vector. There will be only one question vector. And mostly, there will be find their sum or subtraction. That they will give you 2 vectors. What A plus B represents, A minus B, 2A plus B, that's it. You got the point, Ishbab? Never mind, but you have to spend more time on these. The major of your exam is on these: kinematics, dynamics, and equilibrium. Okay, Shabab? This is, please, take care of it. And the announcement today will simply guide you to every topic in the textbook that you can read it. Every chapter, which section you can read, because it's a big book. We are not taking all the sections. Okay, this is what you need. Right. Yeah, Shabab, in the last lecture, if you remember, we stopped at the last slide.
Last slide, yeah.
Yes. We solved this problem, and we solved this problem. We talk about this one, we stop here. Okay, just follow me now. Because this here, this section is related to the next one. So we can go through both. Please, just pay attention. Gentlemen, if you remember, we said that from Hooke's law, he proposed that there is a linear relationship between restoring force and displacement. And we write this here as F spring is equal to K times delta X, where K, this one we call by spring's constant, okay? Is a spring constant. Now, according to this, we know that there is a linear relationship between displacement and restoring. As you stretch more, restoring force will be more. Yes, will be more. So what happened if we draw this graph? You remember this one, that F of spring and delta X, we have a straight line. And from that straight line, we can find the slope, which is nothing but K. Okay? Now that slope, gentlemen, here, K, it shows how stiff is the object. It means K, high value of K, it means that the object is stiffer. And low value of K, the object is softer. From the graph, K is nothing but the slope. So you can say, if the slope is high, that means it's stiff. If the slope is low, it's soft. Okay, Shabab?
Yeah.
Now, let's go to the next part. From here, we will discuss together. We convince ourselves in this discussion, and we will try to make something. We said that we need something more general. Gentlemen, we apply this only for springs. We need something for all solids, not only for springs. Okay? That will. Okay, so what we do here, Shabab? Pay attention. Suppose you have a steel rod like this one. That steel rod has a length L and cross-section area of A. According to the practical evidence, we can say, Shabab, that K, that stiffness, is direct proportion to the A. That means, I will give you an idea. As the cross-section area increases, that object will be stiff. You cannot deform it. Let me give you here a proof for that. If we have two rods, gentlemen, one thin and one thick, like this.
Okay.
They have the same length, by the way. Which one, number 1 or number 2, will be stiffer?
2.
Is there any question about that? If I ask you to bend, ya Muhammad, here, which one you can bend easier? The 1 or 2?
One.
1. Right, of course 1.
Yeah.
So when I say يا شباب 1, it means that 1 is softer. You can easily bend. So can I say that here? Oh, so K is direct proportion to A. More A, more stiff. Right? And vice versa. Why مش have this one? So this is, we agree about this? All of us?
Yeah.
It's something logic, Yasha, but I'm not talking, we talk science now. Now let's talk about the K and L. I need K and L here. I will ask this question, Yasha. You have two roads. This one and this one. They have the same cross-section area. Which road you can bend easier?
2.
Wow, why is 2?
More length.
Just like this marker, Yashabab. You can bend the marker easily. But if I give you that cap,
You can.
it will be very hard for you to bend it. صح? Yes. So can I say the following here? We say also, Yashabab, the same way that K is inversely proportional to L. That means more L will be less
K.
K. We say that this is softer. And this is stiffer. Here we say this is here, this is stiffer. Right, ya shabab?
Yes.
And this is here we say stiffer. So this is here. More L will be less K.
Okay.
And here more area will be more.
Okay.
Is that clear for you, these two things?
Yeah.
Clear.
Okay. Now let's make our general rule. What is the rule? We can write ya shabab, K is direct proportion to the A over L. We combine these together. From the rule, this one, instead of K, I will replace this here by. So I will write from Hawk's law, Shabab here, F is equal to, instead, I'm not going to say spring because we are making general now, not for spring. Instead of K, I will write A over L times delta L. By the way, L or delta X are symbols. Okay, Shabab? Oh, I have something, I missed something. I'm sorry. See ya, Shabab. We should remove this mark first. Yalla, ya Shabab. Group 12. If we remove this mark, you remember this proportion sign, we have to put some constant, صح? Before that constant, we call it, ya Shabab, by Y. Y times A over L. معلش يا شباب، جيبوا بارك الله. Always, if you say something proportional, if you want to remove that proportional and say equal, you should write the constant of proportionality. That constant is called Y. Y, ya shabab, is also constant. It's called, gentlemen, we call it by Young's modulus. Young's is the name of scientist. Okay? It's called by Young's modulus. It's very close to the K also, but K is a sign for springs, where Young's for all solids. I told you from the beginning, this discussion for one reason, to shift from springs to the all solids, to make some more general formula, okay? So if we put this in Hawk's law, we have F is equal to K times delta X, okay? Put this, the value of K here, you will say F is equal to Y here times A over L times delta L. We will arrange now. We done. I will send A to the other side. So it's gonna be F over
A
equals Y delta L over L. This is very, very important formula. Gentlemen, we call this here by the stress. I'm sure that you heard about this word. And delta L that we call by the strain. See? And of course, this is the constant. Now, why we use it for all solids? You can use it for human bones, you can use it for metals, for non-metals, for wood, for plastic, for everything. Even the spider silk, you can use it. Why the K? You remember, we use it only for springs. When you talk about human body, we cannot talk about K. There is no springs in our bodies, right? There is a bones. And these bones, we use the value of Y. Stands for Young's modulus. Stress times strain, and the slope here Allah يبارك فيكم. The slope is y. Okay, see, what is, this is for spring, this is for all solids. Now, K increases, it's stiff, right? Also, Y increases, means also it's stiff. How you know the value of Y or K from the slope? So steeper slopes is indicate for stiffer solids. لما يكون عندك يا شباب عندك الماء العالي أكثر انحدارا, so it means it's stiffer, أصلب المادة. واضحة؟ Now why we concern, again يا شباب, this is we just only we can say shaded on the sprains. Now this is for all solids. This is more general. So please يا شباب, you have to know this is very, very important. واضحة؟ The last point before we proceed. Now the unit of stress is Newton per meter square. Force over area. The unit of strain,
No, you.
yes, no unit. It's ratio, length to length. And indeed, the unit of this one will be Newton per meter square. It will be similar to this one. واضحة لكم يا شباب؟ طيب. With that clear, let's proceed. تعالوا. The discussion of what we talk يا شباب is very straightforward. احنا بسيطة. Now I will erase this. I will show you all these. See, gentlemen, what we have. We talk first of all about K. From here, we find that the spring constant depends on the cross-section area and the length, K. We write the value of constant. We stick this one here, and we have this formula. We arrange it, F over A. What is this? It's called the stress. Delta L over L is called by the strain, and Y is called by, we call by the Young's modulus. As we said, Young's modulus here is a property of material. Do you know what this means? هي شبه خاصية للمادة. Doesn't change. It's a constant. Just like, let me tell you something. Density is a property for material. What is the density of water? Say it. It's 1,000, right? You know, density is something. That means all the pure water, they have a density of 1,000. Okay, when I say also, what is the Young's modulus of steel? It's something constant. It's not changed, just like the density of water. Is that okay for you? واضح يا شباب? When I say Young is a property, please, you should know what we mean by property. خاصية ثابتة يا شباب. Every substance has its own Young's modulus. That Young's modulus. Okay, which is the road made and does not depend on this shape or size. Just like صح. We don't care about how much the size of the water. The water in your tank, or in the glass, or in the ocean, all of it has 1,000 density. صح يا شباب؟ طيب. This is the last one in the first lecture. Let's go to the next lecture. Okay, شباب. Now, if you see here, this is our first slide. We talk about the spider silk. You will see some graph, and we will talk about how that spider silk compared to the steel rod. Look at this here. Okay. Let me just give you this one. I will return back to this. Look at this يا شباب. انتبهوا بارك الله فيكم. This is stress versus strain for steel and spider silk. Okay? Look at the graph. This is, of course, this is a graph. It's supported by here what we call by the scientific facts. It's not drawn like that. This is a real one. Can you give me compare between them about the steel and the spider silk? What they have? تفضل.
Steel is more steeper than silk, so it's more stiffer.
So it's stiffer, right? This is right, 100%. Steel is stiffer than the spider silk. Okay? طيب. This is the first one. The second one. Look at the strain of the, how much is it? It's a 1.
It's at 1.
How much the strain of the steel?
0.01.
If you compare between 1 and 100, that means this spider silk is 100 times can deform greater than the steel rod. That means, ya shabab, I need to here to show you. Strain means degree of deformation. درجة تشوه. Shabab, if you just make a rubber band, if you just stretch it, it will stretch. Something you can detect, right? It has a large strain. Strain, just like you consider the استجابة للقوة يا شباب. It's a large strain there. في large استجابة. In case of steel, طب نفس القوة شد فيها الستيل، هل راح يستطيع نفس المقدار؟ There is a very low strain، صح؟
We can see.
Yes, we cannot see, but we can measure later, صح? So يا شباب, we have a large strain for the spider silk. We have a very low strain for the steel. But something here, both of them, they have the same breaking point. They will break at the same level. We will go back to this, but let me just introduce this for you. Maybe sometimes you will think after, let us go here and we will go back. This is the first slide. See ya, shabab. If we draw F versus delta L, of course, delta L now we use it for solids. Okay? See ya, shabab. Now, first of all, imagine that I have the spring. If I pull the string, stretch it, it will stretch, elongate, then it will return back. There is a limit for the spring. If I exceed that limit, it will not break. It will never go back to its original shape. It will deform. تتشوه, صح? If you continue, of course, it will break. This is the idea. Now this limit, where it will never go back to its here, we call, gentlemen, by elastic limit. You figured out this what I'm talking about? واضحة لكم يا شباب? So, gentlemen, see, from here to this point, this is a line. It's linear. We can apply Hooke's law because Hooke's law is related to the linear relationship. See what is here. F is direct proportion to the delta L. It's a linear or line, straight line. Okay? From this point to this point, in this region, gentlemen, here F is not linear. But what happened if the road will return to its original? It will return, but this we can say is not linear. Now it's not going to obey, we can say obey the law. There's some little bit curve. And finally, if you exceed the limit from this region beyond here, what happened? The road becomes permanently deformed. Yeah, Shabab, see ya. Suppose I had that spring. I'm sorry, I spoiled that spring last week with another group. So I don't have the extra spring. If you just pull it, it will retain. It's okay. Sometimes there is a limit. If you pull, we can say it will not expand linearly, but it will return to its original shape also. This is the idea. It's not linear, but it will return to its original length. But that limit is your elastic limit. Just like, gentlemen, when you say the critical angle, that critical angle, if you have your center of gravity, if you bend yourself, if you exceed that critical angle, what happens? You will fall, right? And there's a question on that. I need to tell you about it. Gentlemen, if you have this one here, and they ask you to find the critical angle, say this is 15 and this is 5, and this is the center of gravity, okay? Now the critical angle, you have to bend this one like this. صح? This is your critical angle, theta C, sorry. Theta C, how we can find it? If you have these, I think there is a question, I don't know who asked me about, but there's a question, Shabab. You can apply what? Tan inverse, because you have opposite and adjacent. A 15/5, and you can find the critical angle for this case. Easy here, this one. I'm sorry, I just disrupt you, but this, I remember this idea now. Is that clear, or I'm talking to myself? أنا شايفكم الآن أنتم هادين. I remember يا شباب the examiner, besides Dr. Abdullah, يعني, he from the last year or the year also before, he liked this type of questions. So I will explain it for you simply. He likes, sometimes I'm not in the exam committee. I don't have any idea about the exam, but sometimes I try to, everything I remember I will give to my students. Don't worry, they will give you a graph like this, Shabab. Suppose. And this is here, and they will give you a graph like this. That object, what is the critical angle? You have opposite, and you have what? Which trigonometric function you can use? Tan. Only tan theta is equal to opposite over adjacent. Shift tan, you find what? The theta. And that theta we call by the critical angle. That angle, if you exceed, you will fall. You, the car, the bus, anything. Is that okay? طيب يا شباب. Let's go back. Now this is my critical angle here, your elastic limit. If you exceed the elastic limit, we say, gentlemen, that the object is no longer elastic, it becomes inelastic now. Now, it will deform permanently here. It will deform permanently. طيب يا شباب, see the questions here. Now explain the following. The linear region. Now here يا شباب, the linear region, this is A. Where the F is direct proportion to what? To the delta L. This is my linear region. Explain the elastic region. This is elastic region. It contains linear and non-linear. How we differ between these? Gentlemen, see. This is linear elastic region. This is non-linear elastic. Okay? But both of them elastic region. Now, the elastic limit, this is your C. And this is your B, sorry. Elastic limit is the limit beyond the road becomes permanently deformed. There is what we call permanent deformation, okay? Now, in which region the material is said to be obey Hawke's law?
Linear.
Only in linear region, يا شباب. Please, لازم تعرفوا يا شباب. Hawke's, we apply only for linear relationship only. To be linear, it should be, linear come from the word line, means straight line, okay? طيب, is these questions clear for all of you?
Yes.
واضحة يا شباب؟ أنا حطيت بس هنا numbers. أنت you just stick it with it. Okay. تعالوا. This is also simple. Now, gentlemen, after the elastic limit, we have a limit where the material cannot afford anymore, it will break. That limit we call by breaking limit. Just like the spring, if we go back, you have elastic limit with an elastic limit, then it will be, yeah, it will inelastic, and if you continue, it will break. صح يا شباب? Now, the maximum, the ultimate stress, أقصى stress, is the largest stress the material can sustain before breaking. This tensile strength is equal to F max over A. This is a stress. When you say about tensile strength is F maximum over A. That's it. Nothing there. We call by tensile strength. So you can add this يا شباب here. We have tensile stress. Tensile stress is nothing but equal to F max over A. The maximum force you can apply without breaking the material. This is the thing. And the point is here. This is your elastic limit here, and this is your breaking point for the material. Now, Hawke's applies here. We say what here, ya shabab? Straight line. From this line, this is non-linear. This elastic limit, and this is the breaking limit. Let's go now. تعال نشوف الأسئلة. Even we talk about this one. Now you're familiar with this. يا شباب, compare between the steel rod and the spider silk. From the figure, compare the stretch of the spider silk and that of the steel. Which one is higher?
Yes.
No. Stretch.
Stretch?
Yeah, stretch means deformation شباب. Spider silk طبعا يا شباب is here higher than steel, okay? طبعا is higher by how many 100 times يا شباب? How you know? You divide this by this one. It's 100. طيب, the breaking point is the same. نعم يا مشرف, right? It is the same, right? يا أخي. Now the last one, the stiffness of the spider silk and that of the steel. Which one is stiffer?
Steel.
Yes, steel is stiffer. Steel is stiffer. Can I say something here below, here between bracket? You say the slope is
Steeper.
which is equal to y steeper. Please, Isha, you try to know this word. أكثر انحدارا, steeper. Okay? Because if you look at this one, how we compare? This is steeper than this one.
This is curved.
Yeah. Okay, شباب. And steeper means أكثر انحدارا. Sometimes we can use it. طيب. Since تفضل.
There isn't a line of region with the spider silk.
It is.
There isn't a line of region.
No, there's, but if we consider a small part of it, we consider it. No, we are not talking about here now, life, okay? طيب يا شباب, جيبوا بارك الله فيكم. Many plant biological materials, as we said plant, we say that it's actually show a large deformation. Rigid show very low deformation. This combination of low stiffness and large tensile strength, we have like a tendons. This is plant, like a wall of arteries. I need to explain a little bit on that. Gentlemen, in our human body, our tendons show that very low stiffness and large tensile strength. Also, the blood vessels, or here what we have, the walls of the arteries, they show that when you run, your blood pressure increases. And all of us, you turn to red. Did you know why you turn red?
The blood flow.
Because, yeah, the blood flow, and you say the blood here, the arteries, they simply expand.
Yeah.
So you turn red. That's true. When you relax again, you turn to your original color again. You see? So we need the walls of the artery should be flexible to give that deformation. It's not a rigid, it should be pliant. Some people, they have the hypertension disease, high blood pressure, they have this problem. But for normal people, when they run, they become red and they have due to that one. We will concern about this. طيب. تعالوا معي هنا. Now we talk about the bones. I think you studied this in biology with
Yes.
Dr. Hashmi, right? What are the different types of bones you studied?
Compact.
And sponge, right. See, there are two types of bones that we have. We have a compact bones. These compact bones simply cover the outer layer of the bones. They are strong and there is no gaps between them. And inside there is a spongy bones.
Yeah.
First of all, if you ask yourself, why it's not there is a spongy? I'm talking physics only. Yes,
Make it flexible.
flexible, okay, and there's something also important.
This weight.
Think, yes,
This weight.
Allah Barak, that's important. Did you know, Ya Nazih, for example, for our cases, of all our bones compact, your mass increase at least by 10 to 20 kilogram. It's very heavy, right? Heavy. Now this spongy makes us actually lighter. When we become light, we can move easier and faster. This is we need it. This is the idea. So, gentlemen, this is the case. That's why in case of birds to fly Z, which
Most
part
of
of
them
them they
are
have?
spongy.
Most of it is spongy. So you can break it easily. I know that. This is for birds. But for us, we have the cortical, which is very rigid and tough, but it is also inside very spongy to make light. And I'm talking beside here, what is inside the bone marrow, blah, blah. I'm not talking about this. I'm talking just only physics here. If you see, gentlemen, we have the cancerous bones or the spongy have a tensile strength of 5, while the cortical has a tensile strength of 100, 20 times greater than that. And there are some disease, mainly, actually this disease suffer from the woman when they give birth to babies, that this part increases and this part decreases. What we call by hashashat al-'idham ya shabab. That spongy part increases for them. They have a less cortical and more spongy. So we said that this type of disease bone disease, they have it. And by the way, some people from men also, they have this disease according to their diet. When somebody say, no, I don't like any type of dairy products. I don't like any kind of vegetables. From where you will get vitamin C, from where you will get your calcium that's required for your bones.
Yeah.
Some people, they like that, ya shabab. Do you ask him, oh, I don't like milk, I don't like any type cheese, I don't like vegetables, and okay, from where you will get your nutrients required for your bones? Day by day, what happened? Your cortical has become weaker and weaker, and sponge increases, and you have that disease. And mainly now it's happening for all people in case of men, and most of the women, because due to that pregnancy and birth. Okay, see this comparison, ya shabab? Cortical. This only you should know. Compact. You know what is the word
Yeah.
compact? Heavy,
Yeah.
tough, with a high value of Young's modulus. This one spongy, light, and soft in nature, and low value of Young's modulus. Now, fills the outer layers of the bones, most of the bones, outer layers, and fills the inner layers of the most of the bones. This is inside. No gaps between the lamella. Lamella, that means the tissue of the bones. There's no gaps. It's compact. Here, there is small spaces or gaps between the lamella. That here. And this is, we see also, ya shabab, in for example, when we eat any kind of meat for cows or for sheep, we see that there's that stronger bones, and when you break it, there is some spongy bones inside. That bone marrow. واضح يا شباب لكم؟ طيب, let's go to the questions now. This question, I will answer it. This is for the birds to make it what? Okay, I need the first question. Who can answer for me? From all of you. This is a very good question. Take your time, and you can use a paper, whatever. I need the answer only.
The first question.
What is your answer? فين يوسف يا شباب؟ لايف اليوم؟ وقاعد على السطح هذا. يوسف السلمي اسمه؟ الله يهديه ويرحمه. طيب. أحمد السقاف. ها؟ طبعا. معكم إجابات كثير اليوم. أحمد السادة غايب صح؟ أحمد عبد الإله، أحمد العلي، أنس شمري، سقاف غايب، إلياس، تركي، حيدر، ريان العنزي، غايب، زيد الدجاني أردني يا زين. لا الدجان بيت دجن هذول. ترى عندنا عائلة كبيرة اسمها الدجاني فعلا، من قرية اسمها بيت دجن، فبسموهم دجاني. بس بعرفوا زيد من وين.
فلسطين. فلسطين.
عبد الرحمن الجابري، عبد الله أبو زيد، عبد الله الرويلي، عبد الله الحامد، علي الخليفة، علي حمادة، علي الجارودي، محمد الأصمة، محمد الغامدي يا شباب، محمد العنزي، هذا غايب ها؟ الشمري، محمد خلف الشمري موجود، محمد منير علوان، محمد الحمراني مشعل موجود، هادي الهمس، هادي هاشم هاشم ما هو موجود. يوسف سليم ما هو موجود. طيب who knows يلا يا شباب نحضر. طب خلينا نحب يلا اكتبوا معي. Why this is important? اكتبوا بارك الله فيك. We start like this. We say f over a is equal to y delta L over L. Okay? Make y the subject. Y will be the subject. I will make it f over a over delta L over L. Alright? واضحة? We arrange this. How we arrange? We write it f over a, put this down and this up. L over delta L. واضحة لكم؟ You know that يا شباب مقام البسط ومقام المقام. I'm not going to say it. Okay, I will here, just here, say, I will write the following يا شباب. Y equals. In the question, he changed two factors. You should know. يا شباب, Y depends on F. Y depends on A area. Y depends on L, and Y depends on delta L. He changed what? L and R. So instead of L, we don't have R here. You can write as follows. F as it is, R we write by R square. You know the area of, here we say that most of the bones, they're made of cylindrical part, right? What is the area by R square? Times L over delta L. Till now, is it okay for you? واضحة لكم يا شباب? The variables we have R and we have L. Now make your general rule. لاحظوا يا شباب. You say Y is direct proportional to the L over R square. We don't care about F or delta L. It's not main. They change only these two factors. I told there are 4 factors. They change only 2. طيب يا شباب ركزوا معي يا شباب. To make this sense now, we change L into what?
L over 3.
طيب اعملها كده انت L over 3 over R to R over. So I will write معلش انا بكتب R capital letter يا شباب. So it will be like that. Y is in proportion to, if this is R will be L over 3 over R square over. So finally will be 4 over 3 L over. صح? This will go up and this will go. So your answer will be B. Ask me if you have anything in that one. يا شباب, I took the first formula. I make it a general formula. That's why I just stick with L and R, because the question they change only these 2. I can change 3 here. I can change 2. I can change 1. It's easy for you. This is our special formula or form of the general formula. And you apply the rule on it. Nothing there. He changed L into 1/3. He changed R into half. But R is, we deal with R square. So when we square it, it will be 4. Okay, and by the way, Shab, by prediction, you will never solve this one. ما تستطيع تحل mentally. You have to solve. The idea, Zaid also here, what we say, Shab, I'm a teacher here. I can change any one of these 4. I can make any combination. I can change F and A. I can change F and L. I can change F, L, delta L. You see? How many options I've got? A lot. This is the idea. Wallah ya shabab, you stick with how to find your own special version of the rule. That's it. For me, I have a lot of options. I can, for example, I said, we change the length and we change the force and we change also the radius. You have to find all of them. Never mind, you find it from that one.
So where is the formulas for
this one? F, y is equal to F by R squared times L over delta L.
and how?
Y, CH. This is numerator with a numerator. This is numerator with denominator. This is direct and this is inverse.
Yeah.
We write up here y is equal, is the proportion to L over.
R.
That's it.
Okay.
Like that.
How did we reach this equation?
How do we change the A?
Yeah, Shabab, A always, we consider it's by R square. الاريا مساحة always we do with the tubes always by r square. ما سمعت عن يا شباب مساحة البايب هذا؟
Yeah, I remember.
by r square صح؟ r for radius r. Okay? I will explain here for you. انتبهوا. شباب هنا هذه بارك الله فيكم. هنا area which is a is equal to by times radius square. Okay? Radius square. And the way radius is half of diameter. الدايمتر هو القطر والراديوس نصف القطر. إذا أعطيتكم diameter 10 إذا radius 5 بس. واضحة؟ طيب. Is there any question about this?
No.
I told you what is the idea of this question. I have infinite number of change any variable. It's not, والله يا شباب, it's nothing. But this, for me, this question will be only for the smarter people. They can solve it. Alhamdulillah, we are not going to predict, ya shabab. There's no prediction in these. Sometimes you can a little bit. If we have one factor change, you can sometimes guess. But in this case, no. And I will tell you something. If I change f, gentlemen, into 3f, I change L into, say, L over 5. I change R into R over 3. See, 3 factors. You write the formula. Oh, you can write them here. Y is direct proportion to F times. We have L over. Is that okay?
Okay.
Yes. Put what is the difference? حط هنا يا شباب. For F it becomes 3F. For L is become L over.
5.
For R is become R. راح اكتبها R square over 9. Okay?
It goes up because
طيب. You just use the numbers. يلا يا شباب. You isolate the numbers. 9 راح تطلع فوق 9 times 3 27 over 5 صح؟ So F L over R square. These two are the same. صح? So what is the difference? 27 over. This is how we solve. This is 3 factors, is it? If we change these 3 factors. F tends to 3F. I wrote this here.
Okay.
L to L over 5. R, what we do, we actually take 1/3 of it.
Okay.
So 1/3, R square over
Yeah,
9,
yeah.
okay? We send 9 upward, يا شباب. 9 times 3, this will go down. This is simple math.
Makes sense.
الله يرضى عليكم يا شباب, okay? طيب. Let's go to the problems now. We have 2 problems, we finish it. I'm gonna solve it here. طيب يا شباب. We have now, this is 2 problems, we solved them. I think these 2 problems are also important. Orb spider has a mass, makes silk with a typical diameter, the Young's modulus, and its tensile strength is. I will write the details. Ya Abdullah. The mass is 0.5 gram, okay? And diameter, how much R?
0.15
الله يبارك.
millimeter.
Over 2 طبعا مليمتر. هذه diameter. هذا طبعا هنا 50 جرام راح نحول بعدين ان شاء الله. Okay? The Young's modulus, it's 0.2 times 10 to the power 10 Newton per meter square. طبعا tensile strength. ايش التنسايل strength؟
F max على
ايوه F max over.
L.
هذا مهم. نعم صح يا شباب. هذا شباب F over A is equal to 1000 times 10 to the power 6 Newton per meter square. انتبهوا بارك الله فيك. See يا شباب. We cannot use different values or different units. عندنا هنا جرام لازم تحولها كيلو جرام times 10 to the power negative. واضح؟ This is millimeter times 10 to the power negative 3 what? This is all. Okay? طبعا clear why we divide this by 2?
Because this the D.
diameter يا شباب القطر
Yeah.
احنا بدنا نصف القطر. أنا بحب أستخدم دائما نصف القطر. That's simple. See the question 1. If the spider suspend itself from a single 12 centimeter long, this is your L,
Okay.
and strand of the silk, by how much will the silk stretch? They ask for what? Allah يبارك فيك, صح يا أحمد. They ask for delta. That means by how much it will stretch, they need only delta L. By 3 centimeter, 2 centimeter, 6 centimeter. Okay, let's write the formula. شباب, F over A is equal to Y, delta L over, this is your formula. والله كلهم موجودين. All of them. F over A is given. هيها. هذه 1000 times 10 to the power 9. Sorry, times 10 to the power 6 equals Y. معلش ارقام كبيره بس والله يا شباب 10 times delta L over 12 times 10 to the power negative. لسه ما طلبها الحين راح تطلبها منك لا تخاف. Is that okay?
Okay.
We can find delta L. بالمناسبة delta L would be 0.06 meter اللي هي 6 سنتيمتر. في غلط عندكم في السلايد عشان مكتوبة 1000 مرتين شايفينها؟ واحدة منهم يعني غلط اشطبها. واحدة منهم غلط مكتوبة بالغلط. في النوتس 1000 they wrote it twice. طيب
دكتور عندي سؤال.
تفضل.
بس نقدر نطلع الدلتا ال بدون ما نحط شنو الفورمولا يعني اف اوفر اي، احنا حطينا بس اف بس ما حطينا اوفر اي.
لا يا أخي هي اف اوفر اي هذا الرقم.
كذا كذا صح.
هيك ما حطينا اف يعني. ما احنا سميناها تنسايسن اف اوفر اي.
إيه صح.
وتعامل معها كانها 1 يونت.
إيه.
1 يونت، لا تعامل معها اف و اي. الحين يا شباب after that question شو بارك الله فيك؟ بسأل سؤال what is the maximum weight that a single thread cell could support? Maximum okay wait. طيب أقول لكم حاجة هنا to answer this question what we use
Need to use grams.
الله يبارك فيك. نعم شباب تنسايل سترينث هذا التنسايل ما هو اصلا معطيك اياه صح؟ تنسايل سترينث is equal to F max over A. اللي ما هي عندنا ايش نستخدم؟
Gravity.
باي R square. مالكم يا شباب؟ مش عندنا ال R؟ اقول لكم تنسايل سترينث how much is it؟ موجود. والR اقدر اطلع الاف ماكس.
Yeah.
That's it. قانون بسيط جدا. You write it and then you just apply for it. طيب بس one more problem عندنا. خلينا هذا. Let's go to the last problem. This is even easier than this one. But I think it's important why it's related to the human body. راح تلاحظوا يا شباب احنا always we go around this formula. والله قاعدين بندندن حول القانون هذا كل مسائلنا. Nothing. يعني حط القانون راح تعرف كيف تستخدمه. See يا شباب, the femur, the long bone in the thigh here can be modeled as a tube of compact bone of most of its length. When I say tube, شو تعرف عظمة الفخذ هذه؟ Tube it means يا شباب you can say A is equal to what? It's a cylindrical tube, cylindrical shape, صح؟ يكون شكله اسطواني زي العظمة هذه. This is the longest bone in a human body. Now I will see the cross-section area of compact bone in the femur of a 70 kilogram person is أعطانا A يا شباب. A اللي هو 4.8 في 10 أس سالب متر تربيع. طبعا الماس 70 كيلوغرام. This is what is given. لا راح يسألك أسئلة. See بارك الله. If this person is supposed his entire weight on one leg, what is the maximum tensile strength due to that? طبعا يا شباب tensile strength ايش يساوي؟ ممتاز يساوي F over A max طبعا. ما عندنا F احنا راح نستخدم ايش؟ mg over.
G over A.
طيب زين it is one leg
So double.
We use mg or half mg or 2 mg عبد الله.
Half.
One day.
2 mg double the weight on the one
We use mg.
MG.
طيب.
Why?
I know. I will explain. خليكم معي شباب. In the previous example يا شباب خليك معي just a minute. In the previous example when we talk about somebody that you remember that sport shoes
Yes.
everything that heel strike
Yeah.
that person شباب when you run you move at that time you actually step in one foot and you raise the other.
Yeah.
That's normal. While you're running, you are not actually applying stress on your weight on one foot. Because you run. This is normally something normal. But in this case, the person is assumed to stand still. When you raise now everything, so all your weight will
Will be in one.
on one foot only, not the both. But when you run, in that example, تتذكروا?
Yeah.
That about runner shoes يا شباب, we explained that spring inside it. There is a heel strike and he raised the other one while he running.
Okay.
So please, while you're running, we take half of your mass, half of your weight, mg. While you stand still, we take all of it.
Okay.
Ask yourself, if I give you the cases, خليكم معي يا شباب. If you run for, say, a certain distance, and you stand like this, which one you feel tired? You stand still, because here, simply, you concentrate all your weight on one foot,
Yeah.
right? When you run, no, I don't have this type of stress.
Yeah.
You got the point?
Yeah.
Please, Ashab, you have to link. Stand still, we use the whole weight. Running, we use just half of it. Okay, Shabab, this is 70. 9.8 and area is given. 4.8 times 10 to the power negative 4. Is that okay? Right. Part B, this question. By what fraction of its length does the femur shorten? They ask for what? L, delta L, L2, L1, I don't know. What the fraction of its length?
Area?
No.
No.
يلا يا شباب, fraction. What the meaning of fraction? كسر.
Yeah.
كسر. They ask for يا شباب, they ask for delta L over L. This is the fraction of length.
Oh.
Fraction of length. طبعا الحمد لله انتم ما قلتوليش fraction, ربطوا لي fraction شيء زي البيجنرز. fraction of length يعني. Just like when you say يا شباب, ايش النسبة? Just like the ratio. Fraction of delta L come from the formula delta L over L ايش بيساوي؟ tensile strength over Y, صح?
Okay.
I will write equal F over A over Y is given for you. F over A, we already find it.
Yeah.
So stick this one and this one. Okay?
Yeah.
Of course, the idea, Zain, here there will be no unit.
Oh, yeah, yeah.
Because it's length over length.
Structure.
واضحة لكم يا شباب؟
Okay.
اليوم أنا شايفكم نعسانين وحستوني معكم. بروح أنام في المكتب. ما أدري شو معكم اليوم، خلص we stop here. الله يعطيكم العافية، كلكم سهرانين على الكيمستري، ها؟ شو راح تسوي أيام الفيزياء؟
سهل الفيزياء. سهل الفيزياء.
صح معك كذا.
أنا هذا شيء يسعدنا. الله يعطيكم العافية يا شباب، بالتوفيق إن شاء الله.
طلع